Hi, this is Lynn Langit for All Things Data. In today's screencast, I'm going to show, demonstrate, and talk about understanding Amazon Web Services pricing. I'm making this because I have lots and lots of requests from customers, and I'm just going to showcase how I understand and use and work with AWS pricing. So to get started, a little bit about me. If you've not watched any of my screencasts before, you can see that I've got an MVP from Microsoft, from Google, from Tengen. I'm a practicing big data architect. I'm also Cloudera certified, and I've done quite a lot of AWS production cloud deployments. I'm also a former Microsoft employee, and I've done work on the Azure cloud. So as I mentioned in the introduction, I'm going to focus in this screencast on the AWS services that I actually use. There are a plethora of services, and this will just be a subset because these are the ones I know, basically. So from a high level, if you take a look at this, you can see that we start on the right with compute and networking, and I've worked with EC2, which is virtual machines, and MapReduce, which is Hadoop on demand. Also, of course, I work with raw storage, which is usually S3 or Glacier. Database implementations, both relational and NoSQL, RDS for SQL Server, Redshift, and DynamoDB. I've done some with deployment and management, not a lot, to be honest with you. I do more proof of concept than ongoing DevOps, but I've done some with Elastic Beanstalk and data pipelines. And then I'm trying out some of the new services with some customers around transcoding, video transcoding, and queuing. That's the SQS service. So many of you are probably watching this because you've been shown or told something like this, and this is from Second Watch, which just shows these huge price differences between on-premise infrastructure and cloud-based infrastructure. And this example here is showing a savings of $218,000 per year. And if it were as simple as that, just move to the cloud, then of course everyone would do it. Now, there's many layers of complexity, and I've covered lots of stuff in other screencasts around application design and architecture and understanding what services are available and what they do and how they compare to cloud-based services. But one aspect, of course, is how are cloud services priced? And I have found, as I've gone around the country and the world talking to customers about cloud services, including Amazon and others, that there's a lot of confusion. So this is a dramatic oversimplification, and yes, you can get to this point, and you may need to for your manager when you're talking about a cloud implementation, but you as the IT pro or the developer have to understand the underlying complexities around pricing along with applications. So to that end, let's dive into it. So as I said in the introduction, I'm only going to look at the Amazon services that I've actually used, either for test or production, which are clearly a subset of all the services that are there. I have tried out nearly everything on Amazon, but in terms of understanding the pricing, I'm going to focus on the services that I regularly use. And this is, if you're not familiar with AWS, this is a screenshot of all their core cloud-based services, grouped by category. So when you're thinking about the pricing model for cloud-based services, the way I like to think about it is your core service pricing. And by core, I mean your compute power, if you're doing infrastructure as a service, or your hosting power, if you're doing platform as a service, your data storage, which is going to be usually a combination of bucketed storage, so like S3, and relational or maybe no SQL. And then you're going to have add-on services. For example, it's very common to need to have static IP addresses. You may want to have some sort of monitoring or alarms or scalability. And there are really just a number of add-on services as well. What most customers start with is they start with the core services, usually VMs and storage, so EC2 and S3 for Amazon. And then there are vanity services. Vanity services are around specialized use cases like the private government cloud for AWS, the education cloud, and I haven't done much work with that, so I'll point you to some resources and talk about some resources at the end. I've done more with the core and the add-ons. But again, you can think of the pricing model kind of like the airlines these days, where you have a certain price for core for your flight or for the compute, if you will, and then you usually are going to get charges for add-ons. So, carrying that extra bag, buying a cocktail on the plane, getting internet access on the plane, so on and so forth. And it's also, I think, a good way to explain it to people outside the technical side of the industry, that it's that kind of a pricing model. Because a mistake that I've seen people make in decision-making roles is that they've looked at core service pricing and they have not considered add-on services. And just like when you're flying on a plane, if you forget about those add-ons, that can actually be a significant part of the bill. So it's a really important takeaway from watching this screencast. I recommend that if you are a new customer to Amazon, first-year customers only can really try out services, and this is something I took advantage of when I was a first-year customer, using the free tier. And they've done a really good job marking their services and marking the different aspects of their services and saying free tier eligible, or if it's not free tier eligible, this is not, or this portion of it is not. Really read those messages when you're trying out the service. Again, a common mistake that people will make is they'll leave services on or forget to delete them, and they'll get these really big bills. There's another thing that you can do that I'm going to actually demonstrate later in the screencast, which is to set an alarm, which can kind of help that. But just, lessons learned. Use the free tier, but read all the dialog boxes. Also, be aware that free tier does not include all the AWS services. This screenshot is from Amazon's site itself. So you can see you start with EC2. You can use something called elastic load balancing, EBS, which is a type of a storage, type of a standard disk storage, and then data transfer, which again is one of those charges that a lot of people don't consider when they're first moving to the cloud. It's not just compute power, it's getting data moved, in Amazon's case, out, which they charge you for. They don't charge you for in. So to drill down a little bit more on the types of pricing, just give you some examples. So I would consider core pricing around compute power. And I'm starting to bring up some terms here that we're going to be drilling into around EC2 that I find a lot of people really don't understand and end up overpaying. So EC2 by default is your virtual machines. And it's difficult enough to figure out what size of virtual machine you need and when you need to turn it on and turn it off. Most people, when they start, they just get on demand, which is your standard pricing. We're going to talk in the screencast about two other types of pricing, reserved and spot, which, in the notes I say higher pricing, but there could be a business case for it. Spot is the cheapest, but again, it's a business case for it. So there's three different types of pricing of one of the core services, really important to understand. Again, as I just mentioned, data transfer charges for in are nearly free, and out there are charges, so that's something that you should be considering. There's something called elastic block storage, which is required for certain other vanity services like provisioned IOPS. So again, you need to read all the different fine print, if you will, just like when you're, taking an airline trip, as to my earlier analogy, to see what additional charges you need to consider when you're budgeting for this. As I mentioned, it's very common to get elastic IPs for production deployments. I know when I'm doing, dev and training and things like that, I don't care about it, but production often need elastic IPs. You're going to pay for that. Provisioned IOPS is another add-on that is common. The one I often using is around SQL Server in the cloud, where you have relational database services, which guarantees a high availability, but you can also optionally use provisioned IOPS, which requires EBS storage, which costs more, and the IOPS costs more. So again, you have to consider all these add-ons and make sure that you understand how much they cost and what value they're going to return to the business. Monitoring and alarms via CloudWatch is another add-on that I very, very commonly use for customers in production. And then I include in the vanity pricing, the government cloud, the private cloud. You have to qualify for participation in the education cloud. They have different kind of pricing. So you always want to look for your particular vertical if there's any sort of high-level solution. There are also vendors that provide solutions and sell on the Amazon marketplace. So you can see on the left you have the size of the EC2 instance, which relates to the number of cores, the RAM, so on and so forth, so the power of the instance. And then I pulled from the Amazon website and I rounded the numbers. The cost per hour for on-demand versus reserved. Now there's a couple notes here. There are many things to consider when you're looking at EC2 pricing in addition to the size and capacity of the machines. First of all, it depends which region you run. So I'll show a chart at the end to summarize geographical cost differences, which is really interesting for me. The cost comparison here is based on something called light usage. So, and I put at the bottom of this page how much savings they recommend that you can have using reserved instances over on-demand instances. Again, usage charges vary for light, medium, or heavy. Light and medium usage require an upfront deposit. This is different than heavy. A really, really important aspect of this is for light and medium, you have to have some mechanism for turning off the instances when they're not being used. And again, this is a very common oversight with cloud-based deployments, that there's this idea to take advantage of light or medium utilization, but there's no plan in place for automating turning machines off, which of course can be done via scripts or programmatic. Heavy utilization instances, you can see the savings here on the bottom. Now, one difference for that is you're going to be charged for those whether or not you turn them off. And how did I find this out? By reading the fine print. You can save even more by reserving for 3 years rather than reserving for 1 year. Another aspect of reserved is that if you over allocate, if you buy too much, you can actually sell it back. There's a marketplace. So again, it's a totally different game from buying physical hardware and setting it up. You got to really think as in terms of what percentage of the time do you need what quality of resources. So again, more about these reserved instance types, because this is where I find a really big opportunity for people to save money. So I have a link to the full documentation here. As I just mentioned, you can sell and buy in the AWS Reserved Instance Marketplace. I'm actually going to show you that in the demo coming up. And here's more guidance from Amazon. I just took this other documentation. This is around the utilization, light, medium, or heavy. What it looks like to purchase a reserved EC2 instance. And one thing I want to make of note here, on the left side of the screen where it says seller, you'll notice that you have AWS selling reserved instances, but you have third parties also selling instances. And this is sort of an eBay-like marketplace. So this is an interesting business model that, again, I find many customers new to the cloud have really no idea that this even exists, and it's a great way that you can save money if you're going to buy reserved instances. All right, so we have on-demand instances, we have reserved instances, and then on the other side we have spot instances. And I took this out of Amazon's documentation off of a slide share. This, I thought it was really well done. Spot instances, to me as a data scientist, are super interesting because these seem to me to be just key and core for doing data processing jobs that can run kind of when there is availability. And you can save huge amounts of money because you'll often want to have very high capacity machines to run, for example, Hadoop jobs, scientific computing jobs, the things they talk about here. But you don't really want to pay the on-demand pricing. You certainly don't want to pay the reserve pricing. You just want a big, powerful machine for a small amount of time. And you're kind of flexible about when it can become available. Another really interesting use case listed on this slide here is video and image processing and rendering. I have several customers now that are creating their own private YouTube, if you will, and they're looking for ways to optimize offloading that processing to the cloud. You can see the request instance wizard, and you have request spot instances. And basically it's like eBay. You say how much you're willing to pay for what size of instance, for how long, and whether it's a persistent request, so whenever that becomes available at that price, in what availability zone, at what size, and then when that becomes available at that price, you're going to grab it and you're going to run your batch processing or your data job. This to me is just golden information for us data scientists. Very important to understand. We can save so much money over on-demand instances so long as the business case is that these jobs can run not on a predefined schedule, because of course you won't get a spot instance unless one comes available at your particular price. Another way I like to think about this is I use hotels.com, and I've been able to get super cheap prices on super nice hotels in California, like $50 for a Marriott. but I can't always get it because it's not always available. So it's the same concept. I put in a price, I put in a location, I put in a number of hotel stars, which is sort of like how powerful or how strong this instance is. And if it becomes available, woohoo, I get it at the cheap price. And if it doesn't, I'm going to have to go and find another place, to stay. Another tool that AWS has is its pricing calculator. So here I am in the Amazon Simple Monthly Calculator. So we have services, and we have the different services along the left, and then we have an estimate of the monthly bill, and then we have customer samples on the right. So for example, if we wanted to put in European web application, it's basically going to populate and show an estimate of your bill. So you can open it up and you can say, all right, it's estimating that compute is going to cost this much. Here's your EBS volume. Here's your IOPS. Here's your Elastic IP. And again, it has this extra stuff because this is a production website. So I really recommend that you spend some time with this when you're trying to understand which services to use. You don't have to use them all, but it'll give you some idea of what's there and what you might want to use. Data transfer out actually costs more than storage in this particular example. Take note of the ratio of costs. And which is the highest? EC2. That's why I talked the most about these alternative pricing schemes, because this is showing you on-demand instances. This is not showing you reserved or spot instances. So let's try a different one. Let's go to an HPC cluster. And you can see that we have S3 storage again, and our highest charge by far is an implementation of compute, which is EC2 with Hadoop or MapReduce sitting on top of it. So we've got $27,000 of compute using on-demand instances. I wonder how much money we could save by using reserved instances or spot instances. Let's go ahead and look at EC2, and you can see that if we want to add an EC2, we can add a description, so I'll just say test, and instance, and here we're putting our usage. So we can say the percent of utilization, the size of instance, and let's say that we want to have a medium instance, and what type of operating system. The billing option, on demand. So here's where we can select our reserved instances. And you can see the on-demand price at 1 year versus, for example, the heavy reserved, it's a 50% savings. And then, of course, we would need some sort of EBS volume because we would probably want to have provisioned IOPS on this, and so we would want to have a volume. And notice we have standard or provisioned IOPS. And then we have our vanity services, Elastic IP, data transfer, and Elastic load balancing. So I'm going to go to reserved instances and say purchase reserved instance. And there were none on micro, but here are some on small. And notice they're all third party. Notice how the prices vary based on the availability zone looks the same, and the offering type is different. So on the light utilization, we have higher pricing. Well, kind of interesting here. And then we have different terms. So notice also that you have an upfront price. When you work with spot instances, you're going to request a spot instance, and let's say I want a spot instance of Windows 2012 base. And I say the number of instances, let's say the size, I want to have small, notice, and I want to pay the current price, it looks like it's 2 cents, so let's say I want to pay just 1 cent. And then I can say I want to have a certain availability group, and I can set the time. Now, in addition to Amazon's pricing calculator, there are also cross-cloud pricing calculators. The one I really like is RightScale. It's called Plan for Cloud, and there are actually many of these. I have some resources at the end. It really helps understanding what services and at what cost are available for most of the popular vendors. So Microsoft, Google, RightScale, and more. There's also an AWS cost cheat sheet. So I'm actually going to go ahead and demo the RightScale Plan for Cloud. I use this really frequently, and hopefully you will too. So you can see the URL up at the top, and I'm going to go ahead and demo this. So you can see here's the main RightScale site, and RightScale, if you're not familiar, is a multi-cloud vendor. They provide templates so that you can have multi-cloud solutions, which is a fantastic capability, but we're going to look very specifically at Plan for Cloud, which is this pricing calculator. So here we are in Plan for Cloud, and you can see that I've signed in. It's free, and what we're looking at is compute power here. So we have the ability to set the CPU count and to set the RAM count. And at this point, you can see we've got AWS, Rackspace, Windows, Azure, Google, SoftLayer, and HP. These are Google over here. But we do have other variables. For example, the Google standard has 420 gigs of hard drive space, whereas the small here has 60. If I wanted to make a change to this and said, okay, I want 4 gigs of RAM, and I really don't want to consider, for example, HP, you can just obviously remove that. Now what I think is really, really interesting is when you go, and I'll put all the filters on, when you go up to the really big guns, again, the data scientist use case, you have really not very many choices. I think if I pull it down, yeah, Google will come in here. You have nothing in Azure at all. So I'd be remiss if I didn't pull up an actual bill. Now my bill for Amazon is actually really small because I tend to only turn on a lot of proof of concepts for a very short period of time. You will get charged for most services for 1 hour, even if you use the service for 1 minute. So Amazon does not have per minute charges, it's per hour charges. But if you, like me, are doing proof of concepts and things like that, you can keep your bill pretty small by first using the free tier, and second by turning off services, and by being really smart about using spot instances for EC2. So I'm actually going to go ahead and show you my bill, and I'm also going to show you how to set pricing alerts. Before I show you my actual bill, I'll also point out that you might want to take a look at this billing documentation page. It's very helpful. And another tip I have is if you have multiple Amazon accounts, which you might, one for testing and one maybe for a customer, you can have consolidated billing, so you can have single billing. Another interesting aspect is you can have programmatic billing access. So you can actually write an application to help you manage your bill. So here is my bill for this month, and you can see that my biggest charge, not like the pricing calculator, but is for Elastic Cloud Compute, so EC2. So a very, very small amount of charge, because in EC2 I turned it off when I wasn't using it, and I use a very small instance just for testing things. I call it my second laptop. Now in addition to this, I'm going to show you how to set a billing alert, which I have found helpful when I've been demonstrating in particular DynamoDB, because you can get charges with that really, really fast, because it has a charge around IOPS. DynamoDB, if you're not familiar, is a NoSQL database. So you can create an alarm, basically. So you select the charges you want to monitor, define a threshold, enter the email, and you get 10 free alarms and 1,000 free email notifications. And it actually uses its own service, so they're dog fooding. It uses SNS, or simple notification services. So again, it's just a wizard. So send, and there was one of my Dynamo ones, send an email to me whenever total charges exceed what, or I can say probably the one I would care about would be EC2. So let's say whenever it's over 20 bucks, okay? And then I just say create alarm, and then of course right now it doesn't have any data because I just turned it on, so it has to collect data. And then it's just as simple as that. So it is very important, if you're working with Amazon from anything other than the free tier, that you regularly review your bill. And it can be tedious, and you can forget, and you can get, you know, really high charges, especially around EC2, if you forget to turn off an on-demand instance. So I really recommend that you set pricing alerts. Okay, so as I've been saying over and over and over, EC2, if it's at any sort of a test situation, turn it off. Or even if you got reserved instances and you're only going to use those to add capacity to a production situation during predicted times of peak load, then programmatically turn it off. It really matters. One of the things, as I mentioned earlier, was geography matters, and I'll show you a chart at the end here showing price differentiation for EC2 by geography, which was one of the learnings I got in researching this. On the screenshot here, you can see that there's a screen around cost optimizing, and you can purchase Premier support for production installations of your application in the Amazon cloud, and that can include the Trusted Advisor and cost optimization report. So Amazon will actually help you to save money because they'll allow you to look at reports that show you underutilized, and you can see underutilized EC2 instances. So you might want to, buy reserved instances with low utilization or a spot or something else. If you don't want to purchase Premier Support, you can also download your bills and perform, basic self-service analytics on them to determine if you can, if your business situation will warrant these different types of pricing tiers. So there's a billing FAQ listed here. There's an Amazon pricing white paper that I've referenced here. There's a pricing spreadsheet. There's a cost sheet. And then there's a tool that is in the suite of tools that Netflix, who's a huge user of Amazon, has as open source on GitHub. It's called ICE, and it allows you to monitor to see what AWS resources you have allocated. So to close out this screencast on AWS pricing, I'm going to switch to another area of technical work that I participate in. I am the co-founder of a nonprofit that creates open source courseware and teacher training materials to introduce children ages 10 and up to programming. You can get our resources at teachingkidsprogramming.org for Java or Small Basic. Also, Pluralsight, if you search on teaching, you can get the C# version of our courseware, which is designed for .NET developers. Microsoft recently recognized our work and has included us in a competition of technical nonprofits. And if you try out our work and you want to support it, just go to azuredevs.com and vote for this as well. And I really appreciate that. So to close out today, thanks for listening. For more technical videos on all things data, including more about implementation of AWS, please subscribe to my YouTube channel at SoCalDevGal and keep learning. Have a great day.